The context for introduction in this video is, firstly, the history of maximum and minimum value. Second, what is maximum and minimum value in differentiation topic? And last but not least is what is the application of derivative related to maximum and minimum value. Firstly, we jump to the history of maximum and minimum value. The figure that we found is Pierre de Fermat, one of the first mathematicians to propose a general technique at duality for finding the maximum and minimum of functions. Second, what is maximum and minimum value in differentiation? When the value of x in the first derivative is substituted in x in the second derivative test, if the value less than 0, then the x value is referred to a maximum value. But if the value of second derivative test is greater than 0, then the x value is referred to a minimum value. Last but not least, what is the application of derivative related to maximum and minimum? The concept is of the application of derivative can be used to find the maximum and minimum value of the given function. In this case, the maximum and minimum value is found to solve the problem of volume or surface area to construct a building or particular things either with the least or maximum amount of the materials needed. So basically, the x value is not given by any function in the question, but we have to find the maximum and minimum value from the volume or surface area formula for a particular shape. In the next slide, we will discuss the problem solving that will give you a wider view about this topic.
So now let's move into the problem statement. The problem statement is, Ali wants to build a pool in his backyard. He wants to build an adult pool with a volume is 2,400 meter cube. His friends suggest he build a rectangular pool that can fit in his backyard. The depth of the pool is labeled as y and the width is x. The length of the pool is 3 times the width, mean 3x. Ali wants to measure the depth, length and width of the pool so he can start to plan his pool. He also needs to know the minimum surface area for his pool to fit in his backyard, so he can save some money for the tiles.
The is 2,400. The shape of pool is rectangular, and the labels y, x, and 3x. So now, we will want to sketch the rectangular pool like this, and label the depth is y, the width is x, the length is times x. So now, since we have the volume, we have to find the formula for the pool. Formula for rectangular is length times width times height. The height is equal to depth. So here we will substitute it with 3x and x and y equals to 2,400 meter cube. And so now we have the volume formula, and we get y from it. Now we have to search for the surface area. For the surface area, this pool have open top, which is the water will fill in the pool, and the top is open. So the surface area will be counted from the front and back, the side, the two sides, and the base of the pool. So as you can see, the surface area, this is for the front and the back, this for the left side and the right side, this for the base. So when we substitute the numbers and the labels, lastly we will substitute the y value in the formula. We will build surface area formula here. For the step 1, we have to find the derivative. Okay, so from the surface area formula, we will find the derivative. You will get negative 6,400 divided by x squared plus 6x. And then for step 2, let dA over dx equal to 0. And you will get the x value, which is the x value is 10.22. After we get the x value for this step 3, we will which is find the derivative and test the second derivative. So from the first derivative, you will have to derivative it once again to get the second derivative, and then substitute the x value in the second derivative. If the value of x is higher than 0, is larger than 0, then the value is a minimum. If it's smaller than 0, which is negative, it will be the maximum value. After that, you will determine the x value is minimum or maximum value. After we determine whether it is minimum or maximum value, you will have to substitute the value of x into y to get the y value. So the y value here is the formula that we get in the first place from the volume. Okay, so you just have to substitute the x value in the y formula. So after you substitute the x value, you will get 7.66 meter for y value. So the width here is x, which is 10.22 meter. The depth is y, which is 7.66 meter, and the length is 3 times x, which is 3 times width. When we substitute the value of x, you will get 30.66 meter. Okay, that's for finding width, depth, and length. So next we move to finding the minimum surface area of the pool. So to find the minimum surface area, you will have to use the surface area minimum surface area formula that we get substitute the value of x in the formula, and then you will get a minimum. That's the answer for this problem statement.
For the conclusion, in this word, we can conclude that the application of maximum and minimum was used widely in our daily life without we realize. The method that we shown in previous slide is helpful for handling commercial or other challenges that require math in daily life.